Well, thank you so much for the opportunity to come chat. I'm Dave Aronchick. As previously introduced, I led Kubernetes on behalf of Google for a bunch of years. I started Kubeflow, and now I'm working on a new project as CEO of a company called Expanso, which is all about distributed compute in a truly distributed way where you're able to bring things universally. So a lot of people, I started to talk, and people always said, well, what the hell does universal AI even mean? And in my opinion, it is all about bringing your AI, your ML, close to the data or your users or whatever, like basically outside of these purely centralized infrastructure. And a lot of people say, well, all right, that sounds nice, but, there are these public APIs that are really easy to use. Why don't I just use them? And more often than not, it's because of stuff like this. The reality is that data is growing so fast, and it's growing universally. It's growing on-prem, networking is not keeping up, and even if networking was keeping up, regulations often will prevent you from moving the data where you would like due to things like HIPAA, financial services, and other GDPR and other restrictions. So, we are going to need some form of new approach to this, because otherwise you get this bottom stat, which is 68% of all enterprise data goes unused today. So that is a lot. I agree with you. But, today people are tackling these problems. They're maybe hand-rolling it themselves, using centralized systems, or more often than not doing nothing. But that's just not going to be good enough if you want to be a groundbreaking company that's utilizing ML. And you may say that is not you, but I bet it is. And these are the things that I see over and over again as I talk to our customers, as I look at the industry, I meet at conferences like this. 3 things that people are often doing when it comes to data. The first is they're often transforming their data before they move it. So you might have a server out there, could be cross-zone, cross-region, cross-cloud, on-prem, you name it, generating any form of data, but your cluster is in some centralized location, and you often have to move it between A and B in order to get analysis. The problem is many. There are all sorts of things that will go wrong when you move just from one machine, let alone, what is more likely, many machines, or just a subset of those many machines, right? It's one of these things that just happens over and over again. People quickly dismiss it, but I'm telling you, this happens all the time. I moved raw data. It was in the wrong format. I moved PII, and I broke some kind of regulation. I ended up with a $68 million logging bill because I moved everything raw instead of aggregating before I did it. It just happens over and over again. You are not alone, but I promise you, this does happen, and probably in your organization. This is a real-world proof of concept we're working on right now. Major American city, 15,000 cameras spread all across the city, and they want to process this. Now, in this scenario, this is a perfect opportunity to apply ML, where you can use something as cheap and easy as something like UML to do analysis, to look for car accidents or slips and falls or whatever it might be. Unfortunately, if they did this, and we did this calculation for them, it'd be 4.4 petabits a day of inbound video. It would overwhelm even Google, right? It would overwhelm even the largest organization if they did this raw. Second, executing over unreliable networking. Now, I would argue that if you have an Ethernet cable, congratulations, you have an unreliable network, right? That is the very essence of networking. It's resilient, but make no mistake, it happens. And whether or not you have a global deployment, or you're cross-cloud, or you're on edge devices, or whatever it might be, you want to connect to all those things, but they will appear and disappear without you knowing, right? Just guaranteed. What does your system have to do to build around this? Now, to be clear, this is all software. You can solve the problem. But the reality is that, that means you going out and writing a layer to deal with that resiliency. And finally, even if things are perfectly connected, but you have 2 organizations that are inside your company but want to run separately, this is another situation where you are going to want to put up barriers. Whether or not it's firewalls, explicit or legally, whether or not it's purely because of data sharing. Maybe they are 2 separate organizations, but you want to share portions of it. You're going to need systems that can take care of that natively. And you building in, yet another ACL, yet another table that tracks these things or aggregates it is not a good strategy. So you say that's still not you. I'm going to put this up here, and I promise you it represents none of you in this room. I have my hyperscale cloud. I am on 3 zones. I have a centralized AI. Maybe that centralized API is still inside my VPC, but it's not. It is still centralized. I have my other clouds maybe. I may have some on-prem or some edge devices. What did I do? What is the first thing I do? I have every one of those things connect to that API in order to process that data, because that's where the model is. I happen to have set it up and made it easy to use. And guess what? Bad guys love that. Because now it means you don't have to go to all those other places to collect that data and know what's going on. You have one place to go. And that one place has one isolated way to go. And it just makes it so easy and so right to do something wrong. It's not saying you are doing something wrong, but you're just making it incredibly easy. Don't do it. There are better architectures. There are different structures. These kind of exclusively centralized, and I'm not saying it is centralized, but I'm saying exclusively centralized is slow, costly, insecure, unreliable. The better strategy is something around compute over data, where you take portions of your job that you ran centrally and instead move that out to the edge. That is a platform that we have launched. It's an open source platform called Bacalhau. We embrace this. This is not the only way to do it, but it is absolutely something. And then, of course, my company, which is in support of this, both architecture and open source project called Expanso. The idea here is you can take your ML jobs in whole or in part, and instead of moving everything into this centralized architecture, you're able to move it in a peer-to-peer way out to all of these places, but reducing the complexity, giving you the same kind of breakthrough, things like Docker Swarm or Kubernetes or so on, with a single control API that let you bridge all of these various networks. So now your ML models can actually go to where your users and data and so on are. Again, it doesn't exclude having portions of your things centralized, but it lets you take care of many of the things that I talked about in this problem before. The summary is it lets you process jobs in place without moving data and limiting the overall amount of leaked information. So let's get to a quick demo here of what that looks like. To give you the lay of the land here, I have created a very, very simple job, actually in partnership with the Activeloop team. This, as you may know, Activeloop just launched Deep Lake today and a global embedded database. And if I just moved all the data raw into that database, I'd be violating everything I just spent the past 10 minutes talking about, right? What would be better is if I was able to take that transformation job, move it out to a number of locations across the world, do my transformation in place, stripping PII, creating embeddings, whatever it might be, and then only moved the results back. Here you can see what this is. It's just raw Python running here. And if I go and I say, okay, well, let's look at this. You can see here, I've created a very simple cluster. I did this last night. It took one command to spin up a 59 node cluster, one for each zone that Azure happens to have, or each region, that Azure has. And across all of these, I can take my job, and let me show you what that job looks like. Here, the job is really straightforward. Just to walk you through, it's, it looks very similar to Kubernetes, but at the end of the day, it just is, takes some highlighted variables and an image, and then mounts in some local information. And that's all it is in order for me to run this. There you go, nothing else up my sleeve. If I take that and I run that job across with that one command, it is now distributing that job to all 59 nodes running all over the world, running that processing job in place, and then producing only the subsets of the results. And you can see that there. Now, this job takes about 5 minutes, so forgive me. I'm going to do that whole Julia Child, show you the one I ran earlier today. But in about 5 minutes, and again, this code is all out there. You can go test it yourself. I'm not lying to you. It produced 41,000 different embeddings using Deep Lake, right? So the Deep Lake API, it was able to produce it and push it forward. Okay, well, what if I wanted to do something more than what you just saw, right? Now I'm going to say, I want to, write a very simple command to, instead of ever having the word centralized go into our Deep Lake repository, I'm going to do this by hand. And here you can see, on top of that previous command, I'm going to run a swap. Now, what this means is that the raw data, which is on those machines, is now having an application, part of my ETL process, being applied over there. If I go over and I say, oh, it's time to run a new job here, the new job, I have call it custom. So just to show you what that job looks like, exact same as before, except I'm using a different container, which I built earlier. But all it does is take that raw Python and move it into a container. And if I go and run that job, here you can see I've now updated that and ran a new job now against 59 new machines, those same 59 machines, but with a different job. Now again, you can do this. You can SSH into every single node. You can create a bash script. You can do all these things. But congratulations, you've now taken on 45 years of distributed computing knowledge in order to make sure you understand how to execute it only once, understand how to be reliable, understand how to do retries, understand how to do a rich API that gives you visibility across all these things. Yet a platform like Bacalhau can give you all that for free. That is what's built into our platform. Okay. And like I said, it'll take a little bit of time, so I'm not going to be able to stay around here, but what it's doing is it's loading behind the scenes, and I'm happy to share this afterward. And again, the code is all open source, so you can go check this out yourself. Okay. So again, that's what we do. That's the philosophy of this architecture called compute over data. Some of the things we've already seen customers do around this. Here you have that same hyperscale cloud we talked about earlier. Let's say they just wanted to deploy a model to a whole bunch of places. I don't know why this went blank. All right, whatever. But let's say you just wanted to deploy a model to a whole bunch of places. You can see that. That's basically what I just did. Let's say I wanted to update that model in place. I can use labels and say, hey, wherever this model is already installed, I want you to update it with this new model. We can do that very trivially as well. Let's say you wanted to do real-time log analysis. Very, very common. Each one of these nodes or things in your system is producing logs. Could I go and do processing on those logs? We're actually in partnership with a major energy company out of the southwest of Australia who have 15,000 microgrids spread across Australia. The challenge for them is that their microgrids are generating data on a per second basis, but their models only require 10-minute windows, which means they're shipping, about 600 times too much data. What they really should be doing is just aggregation at each one of those microgrids in order to reduce their overall bandwidth and make it much easier. That is a platform that we can provide, and that's certainly something that we allow you to do. And what it also allows you to do is bifurcate where you're sending that information. Maybe you still want that raw data. That's fine. But wouldn't it be nice if you had those logs, process some of those logs remotely so that you could send it to an alerting system and say, hey, you know what? We haven't gotten data from this particular microgrid in 2 hours. I want to roll a truck and have that out there. We're still going to keep the raw data, but now we can take more differential action rather than waiting for all of that data to land in my central cluster and process it there. Certainly data migration is a really big thing. A lot of people have isolated islands, siloed data that's sitting on-prem or edge or so on and so forth. We talked to a major TV manufacturer who literally is not collecting crash data at all from their TVs because they can't trust customers' bandwidth. And so we're trying to help them come up with an architecture where they can run trivial log analysis jobs at the point of the customer and just, give some kind of summary around that. But this is very much by doing this processing there on the edge, on the TV, whatever it might be, it means you can now also strip things like PII and other things like that before you move it. And then finally, things like fleet analysis, right? Like just asking, okay, I have this running, this little agent on every one of my nodes in the system. What's out there? What is running with a, bad driver? What is running with the wrong version of, this particular application or a vulnerable library? How do I make visibility into that? Again, that's something we can pull. It's totally up to you on how much you open up to our agents to allow this. But again, this kind of compute over data architecture, it means that I can ship something as rich as OS query or any kind of custom script that I would normally run, but do it in a distributed way. And with Bacalhau, you could also update it, the same thing. So that's Bacalhau. That is the architecture of compute over data. Obviously, I would love to talk if you have particular scenarios and things like that we could talk about. It is an open source project. The project is open source. The binaries are commercial, but we would love to talk. We have biweekly and quarterly meetups and so on and so forth. And we would love to move this entire industry forward. And with that, thank you very much.